Look now at some ways of slicing and dicing the data frame that we just loaded with simulation data from EnergyPlus, from this shopping mall example into this EnergyPlus file. So if we come back down here, data frame objects overview, one thing that we want to do is always put data in data frames in what we call the tidy data format, with the variables as the columns and the observations as the rows. If we go to the Pandas cheat sheet, you can see that up here is an example of a schematic of what a tidy data set is. Here they give the example of force, mass, and acceleration as being these variables in a column, and then an observation would be an example of an object that you're doing some sort of calculation on. And tidy data is really designed for vectorized operations, which means that you basically are able to do the same thing like you do in spreadsheets, where you multiply, let's say, one column by the other to create a calculated column. So keeping it in this type of format as opposed to having data in other formats is useful when using Pandas. So let's take a look at some of the attributes of our data frame. The dot index indicates what the index is. Of course, it's the months of the year because that's what we specified. The columns, we only have one single column in this, which is baseline. So the ability to extract these particular objects or characteristics of this data frame allows us to do other things, which we'll see in the future. A function that we haven't learned so far in the Kaggle tutorials, which I find super useful, is a function called .info. And it's empty parentheses. You don't have to specify anything. What it does is it gives you lots of really cool information about this data frame. It gives you a high level view of what it is without actually seeing the data inside. So here we know that this is a data frame, which we can tell from the first line. The second line is telling us that there's 12 entries in the index. There is a total of one data column. That column it's the only one, and it's the first one, so its index is 0. The name of the column is baseline. It has 12 non-null values, so there are 12 instances. We know that there are 12 instances in the index. There are 12 non-null instances, so we know there's no missing data. And we know that the data type for this column has been recognized as being a float, which is a numerical value that has decimal places. So if there's one column of float, 64 data types. Memory usage is not very much, 192 bytes, a very small data set. So once we get into larger data sets, we're going to see this .info function really help us get a high level view of all the different columns and things that are in a data set. I use it all the time, and I really like the information it gives us. So we learned about this before as well. We can select different columns, of course, in two different ways. One of them is putting the name of the column in as a string and then putting it with brackets. The other way is the dot notation. So we simply say data frame dot, the name of the column name. This is a little less common because if you have special characters or spaces in your column names, you won't be able to use the dot notation. So of course, we want to see subsets. We've done this quite a few times. We've looked at the head of the data set, the first 5 rows. We've looked at the tail of the data set. This allows us to see the spot check of the beginning and end of this data frame to help us just get a sense of what's inside. We can filter the data. We can filter and create a conditional statement that we want to show all the data in this baseline data set that from the baseline column is greater than 10 gigawatt hours of cooling. If we run this, what we see is that it basically cuts off, looks like January, February, and also December, because it's a very hot climate, and those are the lowest cooling consuming months of the year. So we're actually just filtering this data set in the same way that you would in a spreadsheet. At the top of a sorted column, you can actually filter according to different conditions. We can use functions like sample, which is going to give us a random sample of half of the data set. So 0.5 indicates we want to see half of the data set. So here we get 6 months that are just random months. We can specify how many points we want. So here gives us randomly three out of the 12 months. Those are a little less common to use. Sometimes you would use these if you were doing some sort of machine learning or something where you wanted just a sample of the data set. You can sort and rename columns or values in a data set. We could sort from lowest to highest the baseline column by using the function .sort values. And we have to specify what the name of that column that we want to sort. We can also sort based on the index. In this case, the index is the months of the year, and it's going to sort on alphabetical order. This would be different if this was a date, timestamp index, which we'll explore more coming up soon, where it would sort it based on the date and or time. So here we have April, of course, at the beginning, September at the end, based on alphabetical order. We can also rename columns. So here, if we wanted to rename that baseline column, we could include baseline cooling consumption in gigawatt hours. So we could actually change what this is called, which makes an impact on the readability sometimes of the data frame, but also it's used in visualizations, which we'll see coming up soon. We haven't looked at monthly visualizations of data in using Pandas, but it's really simple to make visualizations once you get data into a data frame. It's simply a really often used all-purpose function called .plot. So since we have the data in here, we can just go ahead and do .plot. What we get quickly is a ready-made line chart. That's the default, is line charts. You've got the two axes. You've got a small legend, which is the name of the columns. And you can see very quickly the data. Lower energy, cooling energy consumption early in the year, and the hottest part of the year much higher, and going back down at the end of the year. It automatically scales the y-axis, so you maximize the coverage of what the data you're seeing. It automatically creates the x-axis labels and the tick distances between the number of ticks and the number of things that it shows. This is all hidden away. This is a really fast default visualization of the data. Let's say we want to change some of the attributes of that visualization. We can change the column's name to scenario, the index name to months of the year. We can specify line weight, the color map, the marker, in this case dots. We want the marker size to be a certain size. We want the title to say something different. So you can specify a lot of these attributes, and you can change the data frame characteristics so that your visualization has more customization, let's say. And you can customize almost anything in this data frame. Behind the scenes in this visualization is another library called matplotlib. And in upcoming episodes, we'll learn more about how to modify that, as well as use another visualization library called Seaborn. So let's dive into what do we use these data? We want to look at the difference between the design scenarios. So what happens usually with simulations in the design phase is you're creating a baseline scenario, which we saw in a second, and you are comparing that baseline to potential scenarios. So the first scenario we'll look at is called scheduling. Scheduling is when cooling system demand changes to limit the hours that cooling is available. So in the baseline, the cooling hour schedule is, I believe, much longer than usual. And what we have in the scenario one is that we're actually only limiting the cooling schedule to hours when the building is in operation. People are actually there, which sounds like obvious, duh, but you'd be surprised how many buildings sometimes don't have scheduling down really well in their cooling and heating systems. So let's load the data for this schedule that's already been created called Scenario Aircon Schedules. We'll go ahead and load that guy. Let's take a look what's inside that. Of course, it's 12 months. It's very similar to our baseline model. We look at our baseline scenario again. You can notice January 5.69, whereas January of this one is 5.61. But what we want to do is try to compare these two. We're going to use the Pandas function .concat to basically take these two data frames and glue them together. .concat is really the fastest and simplest way to merge data sets or to combine data sets. And it's useful when your two data sets are really similar, especially in what the index is. So if the index is identical between the two data frames, .concat is really useful to put them together. You just simply call each of the data frames, put them in a list with brackets, specify that you want to glue them together on the index, which is access equals 1, which tells you that you want to be side by side. So here you can see now we have a new data frame called combined data that has both of these data sets in there, baseline and the scenario for aircon schedules. So let's take a look at that data plot. You can see here you have a baseline scenario, and then you've got your scenario with aircon schedules. And you can see the aircon schedule scenario is much lower. You can see the difference between the two, and you can see that the peak especially is much lower. That'll wrap it up for this video. The next one will look at more advanced ways to see the differences between these comparisons, and of course to look at multiple comparisons in one chart.